We said we will talk extensively about layers. Time to keep our promise. Here's arguably the most common pictorial representation of deep neural networks. This is our first layer. It is called the input layer. That's basically the data we have. We take the inputs and get outputs, as we did before. The main rationale behind neural networks, however, is that we can now use these outputs as inputs for another layer, and then another one, and another, until we decide to stop. The last layer we build is the output layer. That's basically what we compare the targets to. Alright, so the first layer is the input layer, and the last layer is the output layer. All the layers between are called hidden layers. We call them hidden as we know the inputs and we get the outputs, but we don't know what happens between, as these operations are hidden. Stacking layers one after the other produces a deep network, or, as we will call it, a deep net. The building blocks of the hidden layer are called hidden units or nodes. Here's a hidden unit. In mathematical terms, if H is the tensor related to the hidden layer, each hidden unit is an element of that tensor. The number of hidden units in a hidden layer is often referred to as the width of the layer. Usually, but not always, we stack layers with the same width so that the layer width is equal to the width of the entire network. Okay, we saw how wide a deep network is. Let's examine how deep it can be. Depth is an important ingredient, as it refers to the number of hidden layers in a network. When we create a machine learning algorithm, we choose its width and depth. We refer to these values as hyperparameters. Hyperparameters should not be mistaken with parameters. Recall that parameters were the weights and the biases. Hyperparameters are the width, depth, learning rate, and some other variables we will see later. The main difference between the two is that the value of the parameters will be derived through optimization, while hyperparameters are set by us before we start optimizing. Alright, this will do for now. Thanks for watching.